Okay, so we have lots of time early on in the course to take our time and make sure everybody understands what's going on. So I'll pause now and ask you if you have any questions about the last lecture or about the assignments, the assignment. No? Yeah.
Excuse me, the third question. Just having trouble with it.
Remind me what the third question is.
It is the MLA form.
Okay. So today we'll talk about strings, and that question is about doing something with strings. So hopefully that'll become clear by the end of the lecture today. Yep.
Number 7 and 8, the way they're written is kind of weird. It's the one we're translated to ounces and pounds and stuff.
Okay. Let me. Probably, well, anytime that the question is difficult to understand, the next place to look is at the sample output. And see if that makes it any clearer. Because, yeah, okay, good.
That would have been great to know.
Does that clear it up? Yeah, so where is it? Assignment 1. There you go. So there's a bunch of questions, and then after there's some testing. So question 7 and 8 asks you to convert one number, which is supposed to be a weight in pounds, and split that up into pounds and ounces. And question 8 is take one number, which is supposed to be a weight in ounces, and split that up into pounds and ounces as well. Is that clearer now? Yeah, good. Yep.
Will we get dot marks if it's not exactly the same? Like for the pounds to pounds and ounces, does it matter if you get like 11.2 instead of 11.30000?
If your conversion is more accurate than the sample one, then you shouldn't get docked marks. So if you go to, I don't know, to Wikipedia or use Google to get a conversion factor that has, 20 decimal places, and I was lazy and just used what I remembered from this when preparing this stuff, then you'll be fine.
Okay, so it has to be more accurate.
It shouldn't be less accurate. I think it would be hard to be less accurate for some of the ones I did.
Well, if you put
I think for example, was there pounds to kilograms, for example, I think I just used 2.2, which you shouldn't be less accurate than that. The true conversion factor is like 2.206 something, whatever. So, yeah. Yep.
Do we need to worry about like comments and documentation?
Yeah, so one thing I showed you last class was how to do, did I show you? Maybe I didn't show you guys, but I'll show you this class, is how to do these simple comments at the beginning of a function to specify what the function does. And we'll see how you do that with multi-line strings today. Yeah.
If we were to make a user interface, would that give us more marks, or are you just looking for the random marks?
Don't do that. Don't do anything that makes that makes your application, or whatever you want to call it, behave differently than expected. So if the question says, write a function that takes a parameter that's in weight in pounds and converts that to kilograms, don't write an application that asks the user to enter a weight in pounds and then prints out some nicely formatted thing. Just it takes one argument and it returns the value. And for the ones that ask you to actually do something that has user input, for example, like this BMI calculator, something as simple as what's demonstrated in the example code is sufficient. And doing much more could get you in trouble with the marking. Yep.
Are you looking for exception handling? So if you enter in like a negative weight?
For now, no, because nobody knows how to do it. But very quickly, we'll get to that where I expect everything that you do to gracefully handle bad inputs. Okay. Yep.
Are you going to at any point do what my old computer science instructor would do, where if you can crash our program in less than a minute, it's a fail?
Well, it's the TAs who end up marking these things, but basically they should never be able to crash your program. So I don't know if that will cause a fail or not, but very soon we'll be making, more complicated programs. In fact, I can tell you right now that the third assignment is going to have you programming a game of your own design, and a game that crashes is very bad. It's going to get you a very bad mark. So, so it's not a limit of 1 minute, but your programs should run, if they're supposed to, they should run forever without crashing. Okay, good. So today I wanted to talk about strings. Again, this is being all the work we do today. The little bit that we do today will be in this shared directory. So some of you have grabbed files out of there from other classes. You can find them there. And I want to show you the different things you can do with Python strings. And some of these will be new to some of you, and some of them will look similar to some of you if you've worked in other languages. For some of you, it'll be very strange. So what are strings? So can anybody give me the definition of a string? In the front row with the glasses.
A length of characters of any variety, be they numbers or letters or anything, that is not intended to be used for a mathematical function in its given state.
Okay, so the short version of that is a sequence of characters, and for so a sequence has a lot built into it. Sequence really means that things occur in a certain order in the sequence. It means that things may occur more than once in the sequence, but there's a specific order, and at least for us, we'll qualify. We can add one extra qualifier, is that it's a finite sequence of characters, although mathematically strings aren't necessarily finite, but at least all the ones we use in our programs will be. We won't have any infinitely long ones. Okay, so let's fire up Python. And there's three basic ways of defining strings. The first and sort of most obvious way is with double quotes. So you begin and end your string with double quotes, and that defines a string. So this sequence of characters here happens to be a T followed by an H followed by an I followed by an S followed by a space, and so on. So that's the sequence of these characters. And this is one that we define using double quotes. If you don't like double quotes, you can also use single quotes. And that's equivalent. You get the same string being assigned there. So notice that when we look at this string, when we ask the interpreter to show it to us, it shows us as this, it gives us this representation here where you actually see the quotes, but the quotes are not part of the character sequence. They're just there to show that this is a string. You wrap the quotes around it to show that. So first obvious question is, well, why did they give you two ways to do it? Yeah.
You need to use apostrophes within your string so that you can use double quotations versus single quotations.
Yeah. So one reason to choose double quotes over single quotes or single quotes over double quotes is that, well, if you happen to be writing a string that contains an apostrophe in it, then you can use double quotes, like so. This is Pat's string with an apostrophe before the S. You use double quotes and you don't run into to any problems. That apostrophe there inside the string doesn't mean anything special. It's just another one of these characters. Whereas if you had tried to do that with single quotes, you run into a problem, because a single quoted string is supposed to begin and end with a single quote. So when it gets to this apostrophe after Pat, it thinks that's the end of the string, and well, then there's some trailing garbage after that that it then tells you is a syntax error. So in particular, Python would think that this is saying S is equal to this is Pat, a string that contains this is Pat, followed by a variable named S, and then followed by a variable named string, and then a single at the beginning of another string. So actually, immediately as soon as it sees this this variable named S, it figures out that it can't continue anymore. It doesn't understand what's happening anymore. So there's one reason to choose double quotes over single quotes, and of course it works in the other direction. If you have a string that has quotation marks in it, so usually represented by double quotes, you can use single quotes to denote the string. So there's a string that contains double quotes inside of it. So there's two ways to represent a string. So another question which comes up then is, well, this shows a problem and a way to resolve it. So the problem is, how do you get double quotes inside a string, or how do you get single quotes inside a string? And the solution is use the other kind of quotes to delimit the string. But where's the bigger problem now? Sometimes you need both. So then you're sort of in a pickle, right? So let's try and edit this this string we did here, in which he exclaims, "This is my string." If he tries to exclaim, "This is Pat's string," then we really have a problem here. If we choose double quotes to delimit this string, we'll run into a problem with the quotation, and if we use single quotes, we'll run into a problem with this apostrophe here. Anybody know how this is resolved? Yeah. Yes.
You could start it with the first quotation, get to this, and then close that one, open a double quotation, put it past, close it again, open another single one, and the rest.
Yeah.
And then put pluses between.
And then put pluses between. That's a complicated solution to a simpler problem. Anyone know another way? Yeah. What's that? A backslash. So this is a really common problem. Anytime you are specifying strings, there's always this issue that, well, there's something that denotes the beginning and end of the string, and that's great and works for specifying strings as long as you don't need that something inside the string. And so even if you have two different ways of specifying strings like we do here, if you need both of those somethings, in this case a single quote and a double quote inside, you're in trouble. And there's a fairly standard solution that occurs in a lot of programming languages, which is when you want one of these special characters inside a string, put a backslash in front of it. So in this case, I have a single quoted string. It has some double quotes inside. That's no problem. But it also has a single quote or an apostrophe inside. So I'll put a backslash in front of that apostrophe to protect it. And then we can see that that works out. And notice when it displays this to you, it shows you, hey, by the way, it shows you this backslash, which is telling you, you know, by the way, this isn't the end of the string. This is just this special character inside of here. And okay, so something else that's a little bit strange here maybe is we're in the interpreter, and when we look at a string, we keep defining this string s and then looking at it, it shows us, we ask for the value of it, it shows us this thing with quotes around it. And it's really important to remember that these quotes are not really part of the string. The interpreter is just showing us these to tell us that, hey, this is a string that you're looking at as opposed to some other kind of variable. So one thing you can do with strings is print them. And if we print this string, well, those quotes on the outside disappear, the ones that show you that it's a string, and all that's left is this, all you see is the sequence of characters here. As well, the backslash in front of the apostrophe disappears, and you just see the actual apostrophe. Okay. And this is actually something to keep in mind when you're working in the interpreter like this in this immediate mode. When you look at a variable by typing its name and hitting enter, you're seeing a little bit, maybe more, you're seeing the programmer's view of that variable. So in this case, the programmer's view of s is that it's a string, and so it shows you the quotes around it. But if you print it, you're seeing, let's say, the user's view, or the nicely formatted view of that variable without these extra quotes around it. Okay. So for example, if I say x is equal to 12, and I look at x, I see 12. And if I say x is equal to the string that contains the character sequence 1, 2, and I look at x, then I see the string that contains the character sequence 1, 2 with these quotes. But if I print them, I'll just see 12. The two are indistinguishable, and if you print them. Okay. So that's something to keep in mind. And when you're debugging in particular, you might do something like, say, somehow wind up with a string whose character sequence is 1, 2, and so you view that and you see, okay, that's 12. Let's add 1 to it, and somehow that doesn't work because you're trying to add 1 to a string, and that doesn't make sense. You might expect the answer 13, but that's not what you'll get. So if I do x plus 1 in this case, where x is the string 1, 2, I just get an error, and it's a fairly, it's an informative error at least. It says it can't concatenate a string and an int. So it's telling you that the first thing you tried, the first of the arguments to plus here was a string and not an integer. Okay. So back to these escape sequences. There's a few of these. So there's this putting a backslash in front of something is called escaping it, but so you can escape a single quote, you can escape a double quote, but there's other things you can escape. For example, the tab character. So this string, which looks like it has a lot of spaces in it that I just entered, actually has a tab character. If we look at it, we see that that's represented as a \t inside a string. Yeah? Can you also print ints? Yeah. So let's do that. X equals 12. X is now an int. Print x, and you get exactly the same thing, basically. So when you print things, you somehow lose information in the sense that now, by printing it, I can't tell if it's an int or if it's a string, because it could be the string that has the character sequence 1, 2, or it could be the int that's 12. You can't tell that when you print it, but if you inspect it, or whatever you want to call it, hit the name of the variable and press enter, you'll see the difference between those two things, whether it's an int or a string. So there's a \t escape for tabs. There is a \n escape for lines. So if we print this string, if you have a \n in the middle of your string, that's treated as a new line. So it's like you pressed enter, but you didn't press enter, because pressing enter would break your code. So put a \n in your string, that adds a new line. And do as many of those as you want. You can make a multi-line string this way by putting /n's in the middle. Here's another one. \r. Anybody know what that is? Yeah. Yeah. What's a carriage return? Yeah. So this new line and carriage return thing goes back to the days when printers used to print one line at a time, and there was sort of two or three things you could do on a printer. You could print a character, and you could advance the paper, or you could move the carriage, the thing that actually prints something, you could move it back to the beginning of the line. So if you've ever seen an old-fashioned typewriter, you see that, well, I don't know, you've maybe seen these in movies, you've almost certainly never used one. There's a handle on the left side of it that you push on, and that moves the page over to the right, which is the same thing as moving the carriage, the print head, over to the left. If you use the handle to do that, it also advances the paper, so you move to a new line. So it gives you both a new line and a carriage return. Yeah, and so this is where this comes from. And actually, this new line and carriage return is the source of endless compatibility problems between Windows or Microsoft-based systems nowadays and every other system on the planet. Microsoft still likes to use a new line and a carriage return to advance a line, and every other system just wants to use a new line. So this causes many problems. Okay, so if I put one of these carriage returns in a string like this, so my string now is A carriage return B, I can inspect that, and I see the string with the escape sequence \A\RB in it. What happens if I print it, given what I've just told you? Yeah. You just see B. If you're really fast, you might have seen the A appear, because what happened is it printed A, moved the carriage back, and printed B on top of A, so it overwrote A. And you can test that by doing something like AX carriage return B, and what will that show you? BX. So it prints AX, moves the carriage back to the beginning of the line, and then prints B on top of A, but the X is still there because we didn't overwrite it. If you wanted to overwrite it, you could put a space after the B. So this is a way to do somehow really cheap animations in a text terminal. You know, you can play around with one of these with using a loop, and the \, vertical bar, /, and minus sign. You can make an animation of something spinning this way. Maybe we'll do that when we look at loops a little bit later. It's also a way to do something like a counter that counts up without having this thing scroll through your terminal window. But it's sort of a cheap form of graphics. Okay, so new lines, carriage returns, single quotes and double quotes. You can put all of those things inside strings using this \/ trick. What's the obvious question? What's the obvious thing that we don't know how to put inside a string right now? What's that? Oh, numbers? No problem. You just put them in like that. No issue there. Yeah. In the front row.
Both the pound symbol and the \.
The pound symbol is no problem inside a string, but the \/ is, right? So basically, every time it feels like when you make a solution to a problem, you introduce another problem, right? You say, well, if I make strings with double quotes, how do I get single quotes? How do I get double quotes inside a string? Well, let's make another kind of string that has single quotes. Well, what if I want both double quotes and single quotes? Well, then I'll put a backslash in front of the one that I want. And now the next question is, well, how do I get a backslash inside a string? So we need to solve that issue and hopefully not introduce another one. Yeah. Yeah. So 2 backslashes in the string represents a single backslash. And what if you want 2 backslashes? 4. Okay, good. So this isn't a problem anymore. Any number of backslashes you can get, you just need twice as many in your representation. But that closes the loop finally, and we can now do anything inside of strings. So I said there's 3 ways to do strings. There's also triple quoted strings, and there's actually 2 flavors of those: triple double quotes or triple single quotes. But they open up with 3 characters. And what's nice about these is that they can span multiple lines. And the carriage return across the line appears inside the string. So if you have a string that you want to span multiple lines, you can use triple quotes. In practice, you almost never do that. Yeah.
Back to the backslashes. I'm writing exactly what you wrote there, and I'm getting a syntax error EOL while scanning string literal.
You sure you have an even number of backslashes before the last quote?
Oh. Okay.
Yeah. Otherwise, if it's an odd number, you are then escaping the quote, so you're not ending the string. Yeah. So with these triple quotes and the 2 versions of those, you can make a string that spans multiple lines. In practice, there's almost only one time that you do this, and that comes back to this question that was asked about whether you have to put comments in your code. The way you use triple quoted strings in Python is usually just for comments. So you use them right after you define a function. Basically, after the def statement, you use an indented triple quoted string, and the convention is the first line of that string is a short description of the function. So what hash thing?
Well, in the the template we got, there was a question 1 with a whole bunch of hashtags around it.
Yeah.
Those were for comment.
They are. They're for a different kind of comment. I can talk about those, but basically the hash says ignore everything after this on the line.
Okay.
So if you put a hash on a line, unless it's inside a string, it means ignore whatever's coming on the line, or whatever's left on the line. I don't know. So here's the kind of thing you would maybe write for your assignment. A function that converts from, I don't know, pounds to kilograms, and you could put a 1-line comment in there using a triple quoted string that says converts from pounds to kilograms, or converts a unit, whatever. It's something that's simple, 1 line, short, should be less than, let's say, 50 or 60 characters long, that describes concisely what this function does. And for more complicated functions, and I'm not saying you should do this for simple things like that just do a simple conversion, you use the fact that this can be a multi-line string to include more information. And the convention there is after the 1-line description, you leave a blank line, and then you put a big wordy description of whatever it is that you're doing. But certainly for assignment 1, everything is so simple that I mean, it's a good exercise. You should be able to summarize this in a very concise way in a single line. Okay. Yep.
And you want that summary to be in triple quotes, or does it matter if we use the pound?
Triple quotes. Triple quotes because that's the convention for these things that summarize, that are at the head of a function that summarize what.
So if you want us to quote each line of code for some reason, that's when we use a hash at the end?
Well, usually you use the. Again, you can use the hash to just block out.
For like debugging?
I mean, you can use the hash to do things like this. Don't do that. So, you know, after a return statement, don't put a hash and say, hey, look, I'm returning something here. I mean, don't just say something obvious in a comment. If there's something tricky happening, you can do it. And in Python, it's actually not recommended to use them to use hashes this way. Hashes should actually be on their own line. So normally, if you're doing something complicated, you know, you're doing maybe it's some complicated calculation, or there's some complicated loop. You could put a single line hash thing that says, now we loop through this array to get all these values, or something that describes what this next little bit of code is about to do. So that's the way you'd use those. Once we start writing a slightly more complicated stuff, you'll see examples of that. But right now, basically, most of our functions are one-liners with a return statement in them, so you don't. Yeah. Front row. Yeah.
I know with most sets of code I've read, and most everything I've had to write, we've had to, or I've seen that it seems to be convention to, in comments in the first few lines of your program, list the program or the date the program was completed and the function of the program.
Yeah.
Do you want us to do that, or?
If you want.
Do you get to ignore
If
that?
you want, at least for the beginning. And then again, in Python, the convention there is triple quotes right at the top of the file. Write all that stuff in as a triple quoted string. Yeah.
So the triple quotes, when you compile the actual program, they won't show up unless you assign, it's a value assigned to the triple quote.
That's right. So, so it's kind of funny because really what you've put in your code here is actually a string, but you don't assign it to anything. You're not printing it, and so it's like there's nothing there in the code, right? So it actually is a piece of code, but it doesn't do anything. So it's like a comment. Okay. So you could use single quotes and get the same effect, but then you can't use multi-line comments this way. So, okay. And I'll put, that's a bad comment. Okay, so now we've seen how to use these things for comments. You can use triple quotes to do these multi-line strings, but it tends to be awkward and ugly, and I'll sort of explain why just with an example. So let's say I wanted to define a multi-line string inside of a function like this. So I say s is equal to a multi-line string. I want to write a little poem. Wait a second. Anybody Australian here? Good. Well, no, you actually may not get it. So there's an example of a multi-line string that's supposed to have a limerick. So a limerick fan from Australia regarded his work as a failure. That's how they would say it if they were Australian. His verses were fine until the fourth line. Question mark, question mark, question mark. And then you see what's ugly about this, right? This looks horrible, to me at least. And the reason is things aren't lined up, things aren't indented nicely anymore. And so let's print this thing. What's the name? September 11th. Yeah, well there you run into problems with indenting. So let's see. Oh, there's the problem. So that works fine, but if you look at the code, it's kind of horrible, right? I mean, we define this function, we assign this variable s, which is a multi-line string. The first line looks great, but then subsequent lines have to be pushed all the way over to the left. Otherwise, we're inserting spaces into this string, and now we've totally lost the flow of when does this function end? Is it over now? Is this stuff outside? It's tough to look at, and if we try and fix it by indenting subsequent lines, well, then we actually break it because now we've just created this string that has a whole bunch of lines in it. Or a whole bunch of extra spaces in it. So that looks bad. I mean, that doesn't work well either. So that's why they're sort of only useful for these multi-line quotes, because they're almost just like comments. You don't do anything with those anyway. Yes, they do have extra spacing in them, but it doesn't matter because nothing uses them. People only look at them inside the code. Okay. So we've seen now that there's this print statement that allows you to print just about anything. You can print strings, you can print integers, you can print any variable that you have. That's great. So that solves some of the problems on your assignment that ask you to print something or to print stuff out. So that's how you can output strings. If you want to input strings, well, there's a method called raw input that's built into Python. It takes one argument, which is a prompt, and so that argument is a string, and it's a prompt that gets displayed to before the input is read. So if I say name is assigned to raw input with the string argument enter your name, then I get the prompt enter your name and a cursor sitting there blinking at me, waiting for me to type something. So I'll put my name in. And now if I look at this variable name that I just defined, it contains the string that I just entered. Okay. So raw input is what I would like you to use for inputting things. If you know other input mechanisms, you can maybe use them, but raw input is recommended. Yeah.
And for numbers then, if you want to input numbers?
So that raises the question. So one of the questions on your assignment says do this BMI calculator where someone enters their weight and their height, as well as their name maybe and some other stuff. So name is fine. That's a string. You can use raw input to get it. But their height, for example, you could read it with input with a raw input like this. So you prompt them to enter their height. They enter something like 74. And then you're going to do some calculation with that, like take height. I don't know what I forget what the BMI calculation is, but you'll do some numerical calculation like this. And this isn't going to work. Anybody know what happened there? Yep.
It printed the string that many times.
Yeah, it printed the string height, which is a string. It's the string with the two characters 7 followed by 4, because that's what raw input returned, and then it printed it a whole bunch of times. So doing a calculation like that doesn't work. If I try and divide it, I get an error saying I'm trying to divide a string by an int. If I try and add some number to it, again I'll get another error saying I'm trying to add an int to a string. None of those things are supported. So really, even though raw input returns a string, I would like to convert that to a number. And actually in Python you can try and convert any type of object into any other type of object. And the way you do that is just by saying what you want to convert it to. So height is the string 72, but if I say int height, then I get that string converted to an integer. And if I say float height, I get that string converted to a float, so a floating point. Yep.
If you want them to input this number, can you just use input instead of raw input?
I don't recommend it. So it's a good short-term solution, but input is brittle. And really, ultimately what you'll want to do is use raw input with your own method of handling bad inputs. So when someone does the wrong thing. Yeah. Yeah, so tell them and ask them again or something, whereas input might crash. It might give you something that's not really what they meant. It's better to give an error and let them recover. Yeah.
Is there a way to do it though without having to be like, what is your height, and then getting that and then converting it? Is there a way to just ask them for a number and then have it actually represent the number?
Well, the shortest solution is to just say height is equal to float raw input, right? That's the one-line version says, you know, call raw input and convert it to a float. There's the one-liner, 72, and now if I look at that result, the height now is actually the float 72, not the string 72. So that's the shortest way to do it. Of course, so someone asked about error recovery or error correction. So if I do that and I type in, as my height, I type in Pat Morin, well actually this crashes the program. So that's okay for assignment 1, but by the next assignment, by the time we do the next assignment, that won't be okay. You'll have to find ways to recover from that. Yeah.
For int height, is that actually converting like height into an int, or is it just like we can read the input and return it?
No, that's right. Okay, good question. So it's not converting, it's not touching the variable height. It's taking the string. So think of int as a function that can take a string as an argument and it returns an integer as a return value, but doesn't change the value of its argument. So just to illustrate what I'm saying here, if I say height is equal to the string 72 and I say int height, well that evaluates to 72, but if I look at height again, it's still the string 72. It doesn't change that. And of course you can go the other way if you want. If you have an integer, you can convert it to a string. So that's x, it's the integer 42. I can convert it to a string using strx. So str is short for string in Python. And that gives me back the string 42. Yeah.
Is there a way to permanently convert the types?
You mean if you wanted to make x actually be the string 42.
Yeah.
Yeah. It's just that. So convert it and then assign the value back to x. And that's a very common. It's very common to change the values of variables this way. You know, you want to add 1 to x, you say x equals x plus 1. If you want to convert it to a string, you say x is string of x. So in general, a method or a function that you call can't really permanently change its arguments. So you know, calling string of x can't really change x. It can return something different from x, but it can't change it. So now you know how to convert between strings and numbers back to strings, and you can convert between different kinds of numbers as well. So if I say x is 42, that's an int, but if I ask for it as a floating point value, as a float, that converts it to a float. So basically these functions, int, float, string, they'll take an argument of any type and do their best to convert it to an int, a float, or a string. And sometimes that doesn't work, and the example is you know, if I can try and convert a string that doesn't make any sense to convert it to an int. You know, if the string starts with a letter, for example, just doesn't work, and it throws a value error. A little bit difficult to parse. Says that it's an invalid literal for int with base 10. At least it tells you what the string was that was invalid. P282 is not any kind of int that it recognizes. Okay, so let's try and put this together and do something really dumb. So let's define a really simple cash register, like the dumbest kind of cash register imaginable. And since we don't know, since we haven't learned yet about looping or conditionals, which we'll pick up next week, this cash register will just read 2 prices, add them together, and print the total. Okay, so should read 1 price, should read another price, add those 2 things together, and print the total. So that's a big, you know, there's a big program, or big list of requirements. Let's put a comment in here that says that's what it's supposed to do. Read 2 prices, add them, and print the total. So we have our comment set up for that. At least we know what the plan is. So what's the first thing to do then?
You have to make the function accept 2 variables.
No, I actually want to read them from the user. So I want to prompt and read them. Yeah.
So you would assign a value using the raw input.
Okay. So let's read the first price. Maybe we'll call it A. And we'll read that using raw input and use some prompt that makes some kind of sense. Price A. Okay, so that reads 1 price. What do we do next?
Same thing.
Let's do B. B is raw input, price B. And now what? To an integer? To a number, at least, some kind of number. Not clear what makes sense yet. So A and B now are just strings. So, you know, we're tempted to finish here because we've read the 2 prices. The next step is to print the total. But if I just do that, it's not going to work. We can try and see what happens. So price A is $1.99, price B is $2.59, and then when I print the total, A plus B, I get 1.99, 2.59. So it's not even a number. And we've sort of seen this already. That's because when you add two strings together, what do you get? You actually get the concatenation of those two strings. So the first string followed by the second string. Yeah?
If you made it just input, we could take numbers as well.
If you make it just input, it can take numbers as well, but I don't want to use input because it's only a very short-term solution when you're first learning how to program. It's better to take a raw input and then handle the case where it's not a number in a different way. So for now, we'll just take a raw input. I don't want you... The problem with teaching you to use input is that you'll learn that and then think it's the right thing to use because it worked for the first assignment, but it's not the right thing to use. So we'll stick with raw input and just know that, well, these strings that we get from raw input, let's convert them to floats before we assign them to A and B. And if we do that, then hopefully our cash register works as planned. So we get that the price is what you get when you add together these two floats, 1.99 and 2.59, 458. So so it seems to work as expected. So there we've seen this example now that this plus operator is somehow special for strings. You can take two strings and add them together using plus, and what you get is those strings glued together back to back, no gaps between them at all. So it's just concatenation. So that's could be the source of some difficulties for you. Now that will let you do some simpler things, maybe like this cash register. Suppose I wanted it instead of just printing this bare price at the end, 458, the sum of these two prices, maybe it should format that a little bit better and specify that what it's now printing is the total. So how would I do that here?
Do the percent sign and put the bracket.
We'll get to that in a second, but using what you know now, how would you do it? Yeah, so I use plus. So the string total plus A plus B, does that work? Anybody guess if that's going to work? Yeah.
Well, it's not because A plus B is a number, right?
Yeah. So there's a couple of reasons that this can't work. So if we look at this, we've now written an expression which is a string plus a number. And one thing we learned is that, well, this plus operator works from left to right. All the operators work from left to right. So the first thing we would be doing then is adding a string plus a number. So even if that worked, I mean, the best we could hope for is that that converted the number to a string and appended it. Then the next thing that's going to happen is definitely not going to work, because if by the same logic we would now get the A converted to a string and followed by B converted to a string. In fact, it doesn't work at all. Python just doesn't let you add a string and a number together. So what we need to do is take this A plus B, and before we use it, convert it back to a string. Okay, is that clear? So now what we're doing is adding two strings together. The string total plus the string that we get by converting A plus B into a string. And A and B are numbers, So when we add them together, we're going to get another number. Just double check that that works. And indeed, we get something that's sort of nicely formatted. Okay. So that's some of the basics of strings. There's another whole category of things we can do with strings that appears in many languages, and probably going back, well, at least 40 years. And that's, I don't know, it's what I call printf formatting. Goes back at least to the first C language libraries. And so how many of you have done printf formatting before? So strings with lots of little percentages inside them and little secret codes. So printf formatting, we'll start with an example. And the way it works is you take a string and you put some secret codes in that string. And those secret codes always start with a %, followed by some other stuff. So you put those inside a string. So here, I want the number %d to appear here. So that's my string. And nothing special about that string. It's really the string I. It contains the sequence of characters I, space, WANT, and so on, a % and a D, all in there. But now you do something funny to that, and you apply the percentage operator. We called that the mod operator when we were using it for numbers. I'll call it the printf operator when I'm using it for strings. And you give a second argument. And in this case, the second argument that I'll give is the integer 42. So somebody want to tell me what this is going to evaluate to? Yep. Either of you?
I want the number 42 to appear here.
Yeah. So this then becomes the string, I want the number 42 to appear here. So where that secret code %d was in the string, it took the argument on the right-hand side and used that as a substitution for that code. Okay. So why %d? Well, %d just happens to be the printf specifier for integers. Yeah, I don't know where that's coming from. I don't think it's the clicking. I don't know if that's the mic or something else. So why the %d? Well, there's a lot of different formats you can use with printf, and %d is just one of them, and it's used for specifying integers. You can include many of these in a string. So I want the numbers %d and %d to appear here. In which case, what you should specify as the second argument is the sequence of numbers you want to appear. So 42 and 29, and indeed that's what you get. Yeah.
If you left it just as 42, would it have pasted it twice?
Well, let's see. If you leave it just as 42, you get an error that says there's not enough arguments because the string is looking for 2 arguments. It has 2 of these special placeholders, and you only specified 1, so it complains about that. Yeah.
So I'm still kind of confused about what the difference is between %d and %s and all these other things.
Okay, so we'll go over a couple of those. So %d is for formatting integers. So it'll just print an integer, nothing special there. Another one of these modifiers is %f. So that's for printing floats. And in particular, it's for floats with a fixed number of decimal places, and there's a default number of decimal places, which is looks like it's 6 in this case. We'll see how you can change that. There is also another way to print floats, and that's with %g. So that's best illustrated if we try and print 42.5 and we use %G as the specifier, the format specifier, then we see that appearing as 42.5. If we use %F, we see that as 42.5000000. So %F is with a fixed number of decimal places. %G is try and use a number of decimal places which makes sense for the particular number you're printing. So we didn't need all those extra zeros at the end to fully understand the number, so %G is a little bit more clever about that. Yeah.
You did like 1/3, so %G would just like infinitely do 3s, or when would it cut off?
Well, let's see. So if we use 1/3, then it gives me a bunch of 3s, so 6 3s. It looks like it'll use 6 decimal places and then give up after that. Okay, so that's how we can do integers and floats in 2 different ways. There's yet another float format conversion, %E. That'll give you scientific notation. So if you take 1/3 and try and print it using the %E specifier, that'll print as 3.333333 to the power times 10 to the power minus 1. So this is scientific notation. You've probably encountered it if you took a chemistry or a physics course in high school, or if you're taking a chemistry or physics course now. So there's that. Another specifier is %S for printing strings. So if you try and do that with, if you use %S for anything, it'll convert it to a string and print it. So it works even if you specify 1/3, but it'll also work if you specify my string. So it'll put that there. And one which is useful for debugging, but not so useful in production code, is %R. And I think R is supposed to stand for raw, which means print this thing as print the programmer's view of this object. So in this case, the programmer's view of the string my string is these characters my string, but surrounded with these quotes. So notice there's a subtle difference there. If you use %S, it just gives you the actual characters that make up the string with no quotes. If you use the raw view, then you get the quotes appearing there. Okay, so %R is sort of useful for debugging. If you're having problems with your code, you can do a printf with a %R to see what kind of variable it is. So for example, that would show you that you can catch bugs like you thought that you had an integer, but really what you had was a string, which was a sequence of characters. Here you can see that clearly when you use the %R format here. So you can use any number of these things inside a string and make it as complex as you want. So that's great. Any other ways? I mean, so far this isn't really exciting, really fancy. We could have done all of, or most of these things just by adding strings together, so using the plus operator to concatenate things. But actually printf formatting gets fancier than that. You can, let's do a simple example so you can really see it. Let's just do a simple floating point format on 42. Well, that gives us a string 42.0000. Well, if I was printing something like a price, then I wouldn't want all of these zeros appearing. Instead, I'd like only 2 decimal places. And for that, there's a modifier that you use. You put after the percent, you put a 0.2 and then the type you want, which is F. And now you get a string which only has 2 decimal places for this representation. Yeah.
Can you use that for %FGNE? Or it's different?
Well, let's see. So if you use that for percentage F, you get the 2 decimal places. If you use that for percentage G, you don't necessarily get the 2 decimal places. But remember what percentage G does. It tries to use a number of decimal places which makes sense for the number that you're printing. But for example, if I tried 42.3736 whatever using percentage .2G, then well, that's interesting. That's a surprise to me. Okay, so percentage .2G. Oh, I know it. I bet I know what that is. So in that case, for the G, this dot modifier actually gives you the number of digits, not the number of decimal places. So that's sort of the magic of printf, is there's all these different special secret codes, and then there's all these different modifiers that work differently for secret codes. So you usually want a reference handy for this, and of course we all now have the best reference in the history of mankind available to us easily, and so if I wanted to know about this, what are the printf formats in Python, I can just Google Python printf format. First thing that comes up is a web page from docs.python.org. Docs.python.org is a reliable source of Python documentation. In particular, python.org is a reliable source of information about Python. And you get a big page. They're actually not very well laid out, these pages, but again, they're easy to search. So look for printf, and you find all these string formatting operations. And you get a giant list of all the things you can use. Percentage D, percentage I, percentage O, percentage U, percentage X, E, F, G, lowercase, uppercase, E, F, G, C, R, S. And of course, the last one is %%, and that's to solve the problem that % introduces, which is, well, once you make % be a special character inside a string, you run into the problem of wanting to print that character. For that, you use %%. So, great. Yep.
Why add an extra piece of code? Wouldn't it not have just been easier for when creating the language just backslash %? Is there a reason for that, or is it just
Well, there's two things. So % doesn't actually mean anything special in a string. It only means something special when you apply the printf operator to a string. So when you have a string and followed by the printf operator, which is the same, denoted by a % sign, the same as the mod operator, then that says go through this string, interpret all the % that occur in this string in this special way, and the arguments on the right hand side tell you what to fill in for these things. So there's no problem writing a string with percents in it, right? You got 95% on the test. That's a perfectly fine string. There's nothing special about that. Even you got 95% D on the test. There's no problem there. It's not until you apply the mod operator to the string that suddenly that %D inside the string means something special. And in that case, if I try this now, or if I do this now, then that %D inside the string suddenly is a placeholder for data that should be filled in. So no extra, nothing special there. Okay, so let's just quickly put all this together to make our cash register a little bit prettier. So So what I would like to do is maybe a cash register that pretty prints everything, produces a receipt, and maybe that receipt should look something like, here's a sample of a receipt. It shows a price, it shows another price, and maybe with a plus sign to show that it's adding these two prices together. They're all lined up nicely so that they line up on the right hand side, and then it shows the total using an equal and the total, and I don't know what's that, 47.98, no, 46.98, 47.98, 47.98. So we'd like the output of this thing to look like that. So how do we do that using printfs? Well, one thing we'd like to, or using these printf formatting is, well, one thing we want to ensure is 2 decimal places. So let's do that. So first thing we want to do is print the first thing as a floating point number with 2 decimal places. So we print A that way. We print B that way. And then we want to print the result, which is A plus B that way. Now we said we also, before the second line, we wanted a plus, and before the last line we wanted an equals. So one to show that you're adding the second number to the first one, and the equals to show that this is the sum. So let's see what that does to our cash register. Can't leave this garbage there. It's not quite what we wanted, right? So we have $45.99 printed, so the first price is printed correctly, but it's stuck over there on the left-hand side, and then we have plus $1.99, so the number of decimal places is printed correctly, but the alignment seems to be all off here. And then the last thing is printed, it's not lined up with the rest. And it turns out that for all of these specifiers, all of these percent specifiers, you can specify what's called a field width, which is an integer that tells you how wide, how many characters you would like this thing to take up inside the formatted string. So in this case, let's do something simple and say, when I print A, I want it to print using 12 characters. When I print B, I want it to print using 12 characters. And when I print A plus B, I want it to print using 12 characters. And I'll put an extra space on the first one to make up for the space used by the plus sign and the equal sign on the next 2 lines. Yep.
Is that 12 on the first print supposed to be on the right-hand side?
You're right. It should be this way. And here as well. Okay. So the format specifier is %12.2f. So the 12 says the number of digits, the 0.2 is the number of decimal places, or not the number of digits, but the actual width, including the digits and the decimal, and the 0.2 says that the number of decimal places should be 2, and f saying that this should be printed like a float. And so let's try that. $45.99 cash register. $45.99 plus $1.99. Everything lines up nicely now. This is taking up 12 spaces. This is taking up 12 spaces, even though it just gets padded out with spaces on the left, and everything lines up perfectly. Okay. So so now you see that this is a little bit more powerful than you can get just by converting things to strings, because if you convert a number to a string, you don't really have much control over how many decimal places or any of this stuff happens. So printfs gives you the somehow the most flexible way of doing it, and they also give you a very compact way of doing it. And just to illustrate that, we'll see that we can do all of this in one line. So with a one-line print statement, we can print A, print B, and print A plus B all across 3 lines by using the new line escape, and everything will line up perfectly if we use these format specifiers. And so let's just test that that works. And indeed, it works perfectly, and the whole thing is 3 lines of code. Okay, so we'll leave it at there for today. Now you certainly know everything you need for the first assignment.
Go ahead.
Sorry?
Go ahead.